How many ways can you arrange 5 books on a shelf? So let's imagine this shelf. It's this bookshelf, okay? And we've got a place for 5 books. 1 book, another book, another book, another book, and another book. So think of how many ways or how many books do you have to choose from to put in the first spot? All 5. How many books do you have to choose from for the second spot? Well, 1 is going to stay in the first spot, so now there's only 4 books to pick from for the second. Now there's only 3 books to pick from, and there's only 1 book, or 2 books, and then 1 book. We talked a little bit about the fundamental counting principle in the last chapter, and that's where you multiply all the possible outcomes and get, I think, 120 is your answer for that. And there's a few different ways where we could actually calculate this. This means 5, 4, 3, 2, 1, all being multiplied, means the same thing as 5 exclamation point. If that's ringing a bell. 5 times 4 times 3 times 2 times 1. Same thing as 5 exclamation point. Also means the same thing if you were doing 5P5. That's your N and your R. And the way I think of it is, this is how many I have to choose from, and this is how many I need or want. I'm choosing from 5, and I want all 5 arranged. And I believe we can get to that in the Inspire calculator. When I do that math, I get 24,360 ways. This is also one of those P problems. I can't really do this with the factorial. That's a factorial with that exclamation point because I need to stop at 28. But I can do 30 people I have to choose from, and I only need 3 of them. And again, I get 24,360. And again, if you're putting in the calculator, you'd be putting 30, 3. Now, this is a little bit different in the third problem. How many ways can you make a committee of 5 people from our class of 20 members? So when you think of a committee, it doesn't matter if they're in the first spot or the second spot. That doesn't really matter with a committee. You're making a group of 5 people. So those 5 people, no matter who I pick, those 5 people are part of my group that I'm picking, my committee that I'm picking. It doesn't matter if I pick them first, second, third, or fourth, or fifth. I'm picking 5 people. So it's going to be a limited number of people. We say this is 20C5. This stands for combination. Combinations are used when order is not important. I'm not ranking these people. I'm just picking all 5. Doesn't matter if I pick someone last or if I pick them first, it doesn't mean anything. Whereas when you come in first, second, or third place, that is where order is important. That's why we call that a permutation. You would get 15,504. You don't need to know this, so don't worry about it. But that's how this is calculated if you wanted to calculate it by hand. Your book doesn't use either one of these methods. Your book uses it almost looks like a fraction, and it will say 20 over 5. And what your book is meaning is not 20 divided by 5, which is 4. Doesn't mean this is a fraction. It means you have 20 items to pick from, and you're choosing 5 of them. And your book also calls this N, it calls this K, but they stand for the same thing as the R did above. So I'm trying to connect it to what your calculator will do. Your calculator uses that R idea, but your book is using N and K. So this means, and it uses this word. How many do you have to, they call it observations. How many observations do you have, and how many successes? I used it from, how many do I have to choose from? And this is how many I need or want. And that's, think of the successes, like if you want to get tails, you would consider a success to roll a tails. Well, I need tails. They're kind of the same thing.